Example 1. Gas is escaping from a spherical balloon at the rate of 2 cm³ per minute. How fast is the surface area shrinking when the radius is 12 cm? In this question, we have been given a rate value. Since the given measurable unit is cm³, then it is related to volume. So, this rate can be defined as dVdt equal to -2. Notice that the rate is negative because the gas is escaping from the balloon. The question asks us to find how fast the surface area shrinking when the radius is 12 cm. This can be written as ds dt when r equal to 12. So, now all the information has been recorded. We proceed with the next step, which identify the equation that relate to the given rate and the rate that we want to find. First, we have dVdt. So, we write the spherical volume formula, which V equal to 4/3 times pi r cubed. Since V is in terms of R, we can differentiate V with respect to R and obtain dV dr equal to 4 pi r squared. Next, because we want to find ds dt, so we write the formula of the surface area of the spherical balloon. It is S equal to 4 pi r squared. Then, differentiate S with respect to R and obtain ds dr equal to 8 pi r. Since we have dV dt and we want to find ds dt, then we need to develop a relationship between them step by step. Firstly, we relate dV dt and dV dr by using chain rule. So, we obtain dV dt equal to dV dr times dr dt. Next, we substitute dV dt and dV dr and get dr dt equal to -2 times 1/4 pi r squared. Simplify this and get dr dt equal to -1/2 pi r squared. Next, we develop the relationship between the rate that we want to find and the rate that we have by using chain rule. So, this relationship can be written as ds dt equal to ds dr times dr dt. Now, we substitute all the known rate and get ds dt equal to 8 pi r times -1/2 pi r squared. Simplify, we get ds dt equal to -4/r. Finally, we substitute r equal to 12 into ds dt and get the value of ds dt is -1/3. As conclusion, we write a statement as follows. Thus, the surface area is shrinking at the rate of 1/3 cm² per minute. Now we proceed with example 3. In this question, we know that the total cost of manufacturing 3 boxes of chocolate is given by C equal to 3p² plus 2p plus 300, which p represents as the number of boxes in time, and it is given by p equal to 2t squared plus 75t. The question asks us to find the rate of change of the total cost with respect to time when t equal to 1. This can be written as dc dt when t equal to 1. Since c is in terms of p, so we differentiate c with respect to p and obtain dc dp equal to 6p plus 2. In similar way, we differentiate p with respect to t because p is in terms of t and obtain dp dt equal to 4t plus 75. So now we apply chain rule to relate dc dt with dc dp and dp dt. Then it becomes dc dt equal to dc dp times dp dt. Now we substitute the dc dp and the dp dt into dc dt and get dc dt equal to 6p plus 2 times 4t plus 75, and let it as equation 1. To complete the calculation, we need to know the value of p when t equal to 1. So, we substitute t equal to 1 into p and obtain p equal to 77. Lastly, we substitute all the known values into equation 1 and get dc dt equal to 6 times 77 plus 2 times 4 times 1 plus 75, which is the value of dc dt is 36,656. Example 4. A 8-meter ladder rests against wall. If the bottom of the ladder is sliding away from the base of the wall at the rate of 0.4 meter per second, how fast is the top of the ladder moving down the wall when the bottom of the ladder is 2 meters from the base? Since we have the figure of the situation, we let x be the distance in meter from the base of the wall to the bottom of the ladder, while y be the distance in meter from the top of the ladder to the ground. In this question, we know that the bottom of the ladder is sliding away from the base of the wall, which we know the distance is x at the rate of 0.4 meter per second. So, this is the value of dx dt. Then, the question asks us to find how fast is the top of the ladder moving down the wall when the bottom of the ladder is 2 meters from the base. This distance is about y. This means we want to find dy dt when x is equal to 2. Now, we back to the given figure. As we can see, we are dealing with a right triangle. So, to develop the equation, we will use the Pythagorean theorem. Since x and y changes as the ladder slides, the hypotenuse of the right triangle shown is always equal to the ladder length. It is 8 meter. Hence, the Pythagorean theorem applies. X squared plus y squared equal to 8 squared. Or x squared plus y squared equal to 64. And we let it as equation 1. Next, we differentiate equation 1 with respect to t of both sides of the equation by applying implicit differentiation. So, we get 2x times dx dt plus 2y times dy dt equal to 0. Because we want to find dy dt, so we rearrange the equation and get dy dt equal to negative x over y times dx dt, and let it as equation 2. If we refer to the known values, we have x equal to 2, but we don't have the value of y. So, we substitute x equal to 2 into equation 1 and obtain y equal to 60, or y equal to 7.75. Next, we substitute all the known values into equation 2 and we get dy dt equal to negative 0.103. Finally, we write the conclusion as follows. Since dy dt is less than 0, we conclude that the top of the ladder is sliding down the wall at the rate of 0.103 meter per second.